Hey, and welcome to a ramble with me. Thanks for tuning in. We are busy with paper 2, November 2022, from the department. Question 9.2. In the diagram, E, B, F, S, and P are points on the circle centered at O. Okay, so we have a center, radiuses, diameters, angle at center, angle from center, intersecting with midpoint of chord, blah, 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 all that good stuff. Okay, right, and we have E, B, F, S, and P. E, B, F, S, and P, okay, are on this circle. Right, I see a radius there, and that's about it. Okay, GB is a tangent to the circle at B, tangent, equal tangents, tan rad, tan chord. Right, so we have a tangent over there. Okie dokie. Tan rad. Tan chord. I don't see any. Oh, there's a chord. But it's not subtending any angles in the alternate segment, so never mind. Right. FE is produced to meet the tangent at G. FE, okay, so off we go over there. Right. OT is drawn such that T is the midpoint of EF. Okay, so this line from the center is bisecting this chord, meaning it is perpendicular to that chord. GO and BO are drawn. GO, BO, a radius. BS is drawn through T. BS is drawn through T. Okay. PS is parallel to GF. Man, I don't know how people come up with these questions. I have so much respect for that hustle. My goodness. I think it takes so much creativity to put this together. Like, how do you think of this? Do you dream of it in your sleep? Anyway, prove giving reasons that OTBG is a cyclic quad. OTBG. OTBG. Okay, so to prove it's a cyclic quad, we want to show that we either want to show that two opposite interior angles are supplementary, or one of the exterior angles is equal to the opposite interior one, which is really not even two sides of the same coin. It's just the same coin, man. Like, if you show that this guy and this guy are supplementary, then you're showing that, this guy is equal to that guy. Because if these two are equal, then that means that these two add up to 180, which means that those two add up to 180. So it is always going to be as easy to show that these two are supplementary as it will be to show that these two are equal. It's maybe just going to take one extra step for the one direction over the other. Anyway, so really I'm just going to stick to one approach. We want to show that two opposite interior angles are supplementary. Okay, and what are we working with here? So either we want to show that this plus that adds up to 180, or this angle here plus that angle over there adds up to 180. I absolutely have no idea where to start, to be quite honest. So I'm just going to start by filling in some of the stuff that's been given to us. Am I able to write while zoomed in? Because I want to write a triangle in a very small space. What's happening? Oh, I can write. Well, that's exciting. So I want to write. This is a 90 over here, right? Because we have the center of the circle, a line from the center of the circle bisecting a chord, so that has to be a 90. And we also know that this angle over here is a 90 because of tan rad. Okay. So, yeah, that is currently what is up. Ooh, say what, say what, say what, yeah. So, I mean, we also know, I'm gonna need this zoom thing a lot. Where's the little triangle? Oh, there it is. We also know that this angle is equal to this one. Ooh, I'm really pushing it, aren't I? Because of vertically opposite angles, right? So that would mean that this angle is equal to that angle, right? Because yeah, this is a 90, these two are equal, so the third angles must also be the same. I don't know if this helps us in any way whatsoever as yet, but this is where we are. Okay, we are in struggledom. Yeah. Let's see what these parallel lines have to offer. I don't know. Do I want to go there? No. I do not. We have a tangent. Do we have any cyclic chords? I don't think so. Like in this circle, I don't see any. Okay. Okay, this angle is equal to that one. Alternate angles. It is also equal to zoomy. Also equal to this angle, because of corresponding angles, right? Right, so those are equal. So I am curious about an expression for this angle here. Because now what I'm seeing is this angle, Mr. Purple, and then 90-degree over there, and the little sliver over here, those are cointerior, so they add up to 180. And what do we have so far in our OTBG? We have Mr. Purple and the 90, right? And across it we have this Mr. Green and something else. And I suspect that this angle is equal to this little piece over here, because then we would know, okay, this guy plus the 90 plus Mr. Purple is supplementary. So that's my mission, to show that this is the same as this little piece over here. All right. Yeah. How do I do it? Hee 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 hee. I mean, I did think about extending this somehow. Yeah, I have to extend it all the way to the parallel line in order to get this, you know, some relationship with these out there. I don't know. I promise I'm gonna share my thoughts, and I'm sharing them, but they're not very productive right now. Okay. If I, not what I'm trying to achieve, but anyway, if I extend this, I know that that is also a 90, because, because parallel lines, and this is a 90, so co-interior angles. And it's a line passing through the center of the circle, so this is also going to bisect, I mean, whatever use that is. Why did I do that? I'm doing that because I'm really desperate to get something about this. Oh, maybe I will. So this is a 90, yes. And what does that tell us? Well, not much. This is a 90. Oh, it's getting messy. The only other place we have purple is here. I mean, so that doesn't really tell me much new, right? So we could have already deduced from in other ways that this is the same as 90 minus purple dot. 90, let's use the same colors, seeing as my colors are significant in this current scheme. Right, just by looking at angles on straight line, we have that 90 over there, the dot, so this must be 90 minus the purple dot. So I want to show that this over here is the same as 90 minus purple dot. Oh, I'm at that point where I just need to erase and start again. Right. Okay, so what do we have? We have center of the circle O. GB is a tangent. Okay, fantastic. Love tangents. Right, FE is produced to meet the tangent at G. Okay, so this is one long happy straight line. OT is drawn such that T is the midpoint of EF. Okay, so right, GO and BO are drawn. BS is drawn through T. PS is parallel to GF. Right, and we need to show that OTBG is a cyclic quad. Okay, so maybe I'm focusing in the wrong place. Maybe it's not these two that I'm going to win with. Maybe I'm going to win with these two. So, right, let me bring my little zoomy thing again. So we said that this is a 90. Happy with that. And we also know that this one is a 92. Okay. Yeah, there's actually quite an advantage with this zoomy thing. I can write knowing where I'm writing. Okay, right. So that's a 90 because of tan rad. Okay. Then if I just call this guy blue dot, who else has relationships with this blue dot man? Okay. And what about this one over here? Any hits there? So this is a radius, and this is some chord. I don't know. I don't know who it would be related to. Yeah, no, using colored dots all over the place is probably not the plan, not the vibe, you know. But sometimes when words fail you, all you have is the little dots. Okay. I'm pretty much going back to where it all began. Where star is 90 minus the green dot. Alright, star and the orange star and the green dot are complementary because of angle sum in a triangle. Right. I'd really love to get an expression for this angle. I know I wasn't meant to be obsessing over that one, but I'm back because these ones are not giving me any joy. So this guy over here is 90 plus x, because exterior angle of of this triangle here right, so it's equal to this plus this. And I just changed it to an x. It's a star, man. The star. Okay. Okay, let's try get fewer colors up in here, So, when a gray, I'm thinking is the same as green, green minus purple, right? Same reason, exterior angle of triangle. So I'm just gonna get rid of gray. Oh, jeez, guys, violence is not the answer. So it's going to be green minus purple. Okay, so that's everywhere where there's a gray. So green minus the purple. And I think we had another one down here. Green minus purple. Okay. Right. I mean, one would very rightly wonder why I have orange. So I need to get rid of orange too. So orange is just 90 minus green dot. So yeah. 90 minus green dot. So out here it would be 180 minus green dot, and then this would be 90 minus green dot. Okay. Right. So I'm going to get rid of this guy. Hasn't really given us much up until this point. Okay, looking at that tangent again, thinking about what else it can give us. It's given us tan rad, for which we are very grateful. The question was, you know, does it give us a tan chord or something? So here's our tangent. Here's the only chord it's connected to. What angles does that chord subtend at the circumference? Zilch. So there is no tan chord for me, which is a bummeroo, to say the least. Okay, so what angle would I love with all my heart? I would love an expression for this angle EGO. Ego. Which maybe angle BOG could give me, if I could find an expression for that one. Oh my goodness. Oh, golly golly. Okay, so this angle here is, so this whole angle is a 90 as well. So this angle will be 90 minus 90 minus this, right? Because this is a 90 as well, right? So this is going to be 90 minus green dot minus purple dot. Okay. Which is the same as 90 minus green dot plus purple dot, right? So we now have that angle, and what does it even help us with? So I was hoping initially with my first approach, I was hoping to show that this angle is equal to that. No, I was hoping to show okay, so we know that the 90 and this add up to 180. They're co-interior angles, and you know this, the dots are gonna cancel out, so the 90 plus 90 gives 180, so definitely co-interior. And what we have here, we have the 90 and this, right? So if we can show that this whole angle is equal to that, then we've shown that it's supplementary, that the two are supplementary. Well, this and this are supplementary. So what are we missing? We just need to show that this is purple dot. But how do you expect me? Well, okay, so we know that this little angle, dealing with little angles here, we know that this little angle is 180 minus green dot, because angles on a straight line. And we have 180 minus green dot over there as well. So if I can show that this is equal to that, then it will follow that this is equal to that. As well, how to do that, I don't. Oh, and this is the other thing. Oh, proving it's a cyclic quad. Oh, mental explosion. Oh, guys. Oh, I apologize profusely. It's been right under my nose, right under my nostrils. Right, so to prove that a quadrilateral is a cyclic quad. Oh, I can't believe I forgot this. Okay, so to prove that it's a cyclic quad, oopsie, sorry. You are either going to do what I initially said, right? You're going to show that these two are supplementary, right? Or an extension to that would be to show that these two are equal. But like I said in the beginning, those two approaches are pretty much, you know, the one will give you the other. The other way, very important, the other way is to show, if this is your cyclic quad, you want to show that if you drew the diagonals in, any of these pairs of angles are equal. So you could show that those two are equal, or those two are equal, or those two are equal, or these two are equal. Oh my God. Right, and this is such a so this particular one is such a prime one for this one, because you have the diagonals. Once you have the diagonals in there, it immediately hints to using this approach. Oh, guys. Oh, I don't even want to know how many minutes I just spent running in circles, but thank you, God, for your intervention. Okay, so we have seen that this angle is equal to that angle, which would prove it. This angle is equal to that angle, which would prove it too. What other pair do we have? Okay, this one was the one we were struggling with, and this one was also another one we were struggling with. Okay, so anyway, wow. The horror, the pain in my spleen. So the moral of this video is, guys, you must study for your exams. Really, make good notes and study. Right, okay, so we know that OT is perpendicular to EF, and that is because we have a line through center bisecting EF. Right, so we know that that's a 90. Then we also know that OB is perpendicular to BG, and that is because we have the tangent BG being perpendicular. You know what? In this case, I would just say tan right, because really the tangent and the radius are named in the statement. Right, so therefore angle OTG is equal to angle OBG is equal to 90 degrees. And therefore, therefore OTBG is a cyclic quad. And the reason for that is, I'm not sure how you say this. Do you say converse of angles in same segment? I'm guessing. Man, I'm so bored of myself. So bored. Let's just move along before I cry. Right. Then, next up, we are asked to show that GOB is equal to S. GOB is equal to S. Okay. So, I mean, we do know that, yeah, easy man. Oh. I'm just continuing to grieve, man. I'm just continuing to grieve because how could you do me like this, mathematics? So I'm just going to draw in the circle that we got. You know, sometimes proving that you got a cyclic quad in the previous question does turn out to be useful for the next question. Sometimes it doesn't. In this case, it is useful because what stood out for me was, okay, we're trying to show that this angle is equal to this angle. So I was trying to figure out, well, okay, what other angle does this have a relationship with? And it has a relationship with this angle in this circle, right? Because it's angles in the same segment. And this angle is equal to that angle because of corresponding angles. So, yeah, I would say that if the previous question, you know, asks you to prove that you have a cyclic quad on your hands, in the next question, the follow-up questions, definitely try and see if it can help you out. You know, if it can help you form some bridges. Yeah, I'm grieving for myself. So GOB is equal to angle BTG, right? So that little angle over there, and that's because angles in same segment, right? And then from there we say angle BTG is equal to angle S because corresponding angles PS is parallel to EF, right? And therefore GOB must be equal to S. Definitely putting timestamps on this one because that suffering was not necessary. That was not grappling. That was just forgetting. Forgetting. A very important thing that you shouldn't forget in an exam. Right. Yeah. We have the same thinking. Ooh, guys. Ooh. 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 Wow, I can't believe what I've just gone through. Anyway, thank you for coming around to witness this horrific show. Remember, there are 2.5 ways to prove cyclic quads. Very important to remember that there are two options, so that you don't bash your head against the wall trying to show that two angles are supplementary when the pots are just not cooking. Okay.